session is on a topic called containers. The session is titled that Containers Beyond Virtualization. So before saying anything, I'll introduce myself. My name is Janaka Rangama. I'm a Microsoft most valuable professional for cloud and data center management practice. And I recently joined with Virtusa as an associate architect for their cloud practice. And I do blog here and there. So if you want to read, if you read blogs and want to get ahead of this technology, here's my address, blog address. And a little bit about me. I'm also a Microsoft certified trainer on a plethora of platforms and technologies, and I'm a Azure Solutions Architect. So in my day job, I build clouds. I'm a cloud guy. So whatever the technology related to cloud, AWS, OpenStack, or whatever, I'm quite familiar with it. And I'm one of the community leads for one of the forums here in Sri Lanka called Sri Lanka IT Pro Forum. And this is actually the second kind of like local conference that I've been here in Sri Lanka. I've been all over the Europe, APAC, to deliver sessions on these technologies. And that's about me. Okay, so before starting anything else, can I know in your companies, in how many companies that you work on, are you familiar with the term called virtualization, virtual machine? Raise your hand if you ever deployed a virtual machine and know what a virtual machine is. Okay, I see quite a hand. Okay. Now, in today's session, what we are going to discuss is when you deploy your applications, what are the challenges that you don't see but your IT team sees, right? So when you want to deploy your application, what you do is you put the code, package it, and give it to the IT team. You don't care how much RAM and whatever the servers, whether they are out of budget, anything, you don't care, right? You just want that application to be executed properly, right? We are going to see some of the challenges they face. And maybe if you are coming from a DevOps background, you face. And then we are going to see what this technology called containers are. And then we are going to see a couple of popular platforms and type of containers. Me being a Microsoft MVP, I'm not going to discuss into depth on the Linux container side, but into the Windows containers and how these containers contribute to the DevOps process. And I have a simple demo on running a simple application straight from Visual Studio and running a container from PowerShell using a cloud platform. Okay, so Datacenter challenges, right? Even though we say this application is tested and everything is working fine and everything, if you go to the data center, the first thing you notice is a messy table or messy rack of servers with, there might be not a proper color code, there may be some legacy servers like that, right? So that is actually what us IT professionals see, right? But in terms of the resources, right? So if you are a developing company deploying thousands of applications, the more clients you get, more applications you develop, more resources you need, right? And you should have a continuous integration and continuous delivery as well, right? So now you want to say deploy it into multiple environments, QA, dev, test, like that, right? How do you do that? And then you may be using one or more physical servers, and then again virtual servers. What a virtual server means, you have one physical server, a PC or something like that. Inside that, you are running a couple of virtual computers or virtual servers or virtual machines, right? So these are some common challenges that every organization, developer, and everyone faces. So can I know how many of you are using your development on your local laptops, PCs, whatever, using your own virtualization platform? Anybody? Okay. So at Microsoft, the technologies Microsoft deliver, any developer who wants to deliver, create an application or like that, they are not going after IT for resources. They are given their own virtualization space. Say, if they say, okay, I am developing 10 applications, my requirement is to have like 20 or 100 virtual machines, they just give it. So you are responsible for your own infrastructure. Okay? And again, now everybody is saying cloud, cloud, cloud. So I'm a cloud expert. Sometimes I've had enough of this word called cloud, and if someone asks me what is cloud, I say it's a cloud. That's it, right? and everybody is talking about this in a big hype, and how do we move this application to that? There are no physical servers, there are virtual machines, right? And it's a shared space. How do we better utilize that? So these are some challenges that in any application development that we face. And again, maybe sometimes you want to deploy this application to your on-premises hardware as well, and you want to put some application in the cloud. How do we do that, right? Okay, now I'm moving into an entirely different topic. If you want to move something before 1960s, right? How did you do? So don't think this as contraband, okay? You may have used any of these methods, right? You may use railway, and you may use ships, whatever, right? So how many of you seen these big prime movers with the word Musk in it? How many? Everyone has seen it, right? The containers that go in the road, right? Why do you have that in? Whatever you want to export, you put into this big box and you send across to the faraway countries, right? So this box or the container acts as the medium of transport, right? Okay, so the concept of containers in our field is pretty much similar to that, but here what we transport is our applications. Okay, so then I think some of you might get in the question, okay, we have virtual machines, right? How this differs from virtual machines? I'm coming to that point. And the advantage is, now irrespective of the environment, that means whether it's on-premises or cloud, you can use the same technology to deploy your application. Say, if you have developed a containerized application for an on-premises Windows server or whatever there is, and you want to take the same application to the cloud, you are just moving that container to a container host in the cloud. That's it, right? So if you have like for your testing purposes, development purposes, right? If you want to provision like 1,000 machines for 1,000 applications, if you can put all those 1,000 applications into 1,000 containers, you may want to use a single computer or a single virtual machine or a single physical server, do that. Okay, so what is containers? Actually, it's a new approach to build, ship, deploy and instantiate applications, right? So if you take the traditional physical server infrastructure, whatever the servers that are in big data centers, you may have a couple of applications installed, right? Whenever people trying to log in and put more data and make it more bulkier, it will get resource hungry. So most probably some organization use one server for one application. Then it comes with this virtualization hype, okay? Use couple of servers, couple of machines, right, as virtual host, and inside that you put couple of another virtualized servers. So it uses virtual hardware, and again you deploy your applications, but it will be the similar way, right? Previously used one server, now you are using multiple servers inside of one server, but the resource utilization that never ends, right? If you are coming from a client background, you know, if you are doing a improvement or a new applications, the resource hungriness for developers never ends, right? The IT team might come and say, okay, here, look, you have asked me 10 virtual machines, 10 servers, I have given all. Now I can't give you more. What do we do then? Then we get this concept called containers. And again, there's an advantage over this physical hardware on virtual machines. You get high availability, right? Any virtual infrastructure, you can make it highly available. So if one physical server fails, the same virtual machine will run in another physical host. But how that differs from containers, right? The same example I've shown you. You take a box, you put the application there, and you keep couple of those boxes there in a server. Has anyone used a software called Sandbox before? Sandbox, right? Why do you use that? You get your separate kernel, separate environment inside a single OS, right? So the applications won't be bothered from any of other. Now in this concept also, we are talking about operating system level virtualization, not hardware virtualization. Hardware virtualization is you get a physical server, put virtual machines inside it, and each virtual machine has their own operating system with emulated hardware. But in containers, this technology, you have a physical server, okay? You are virtualizing the OS. So each container is isolated from the other, right? Like a big container yard. You may have a couple of, say, bikes in one, maybe contraband in the other. They won't conflict until the customs come, right? So how this technology is designed, right? So for any application or any this technology to run, there should be a physical server. Maybe Windows, maybe Linux, maybe another OS, right? So usually how do we do that is, we put a host operating system that supports containers. So Windows is one of the operating systems that has containers. Red Hat and Google has their own system, right? And then you put something called a container management stack. So anybody heard the term called Docker? Docker? Few people. Okay, Docker is a familiar container management engine. Okay. So on top of that, you deploy these boxes called containers. So the other thing is, now this is not kind of like full virtualization. This is very lightweight. For an example, if you virtualize a system, it may have a big like 20 GB, 30 GB OS footprint, but this one does not. This may be for 100 megabytes, 50 megabytes, depending on the application, right? And it has its own binaries and libraries, right? It won't utilize whatever that is there with the operating system. So you can isolate it. And then again, now it's a shared user space, right? And shared user space means you have single OS, but you have parked your containers inside that OS, but within that containers you have your own applications, maybe kind of like binaries like that, right? So basically the server will be the parking space, okay? And you can deploy anywhere. That means whether it's cloud, on-premises, or client-side, or hybrid cloud, anywhere, if it's compatible with the technology that you're using, you can deploy it. And again, it's fast, right? Because the applications that you have today, most of them may not be compatible with containers, but if you can containerize what you are developing, so the way you build it and deploy it would be much faster. Now, the differentiation between containers and virtual machines is, now virtual machines has their own OS, right? So you have to manage the patches and everything. But inside a container, you are not focused on patching that container and whatnot. And again, how you deploy the application? You have a repository. From there, you get your container image, that is the package application, and deploy. Okay, what is Docker? As I explained, it's actually an open source engine which is supported on Linux and Windows as well. So most of the cloud providers like Azure or AWS support this container technology, and they have their own operating systems that supports this. So anybody working with the latest version of Windows Server 2016 might know the container technology is available there, and all of the Linux distribution, most of it, are compatible with this technology. But remember, these are two different things, Linux containers and Windows containers. So obviously you can't run Windows containers inside Linux and Linux containers inside Windows, right? You may have deployed a package that can be put into both containers, maybe Linux or maybe Windows, right? But you can't do like cross check on that. Okay, and couple of key terminology. Docker client. So client is basically, it's a command prompt, command line. So you use this client to manage your containers, delete, create, you can use it. But if you have any IDE or any development technology, you can use that obviously as well. So Docker daemon is the Docker service or the management engine service that controls that everything goes on inside the container host, right? And you have containers. Docker Hub is the central repository where Docker puts its container images. And this is, I'm talking about one platform, that is Docker. If you have your own private registry, you can keep it there, right? For an example, for Windows Server, you can have your own private repository to keep your Docker containers. And you have this Docker images, right? Image is a packaged application which is templated, so you can use it there. And so I'm talking about little bit on Microsoft technologies. So if you take how Microsoft see this technologies, so they are pretty much in line with the Docker's vision in containers. So the Docker engine is available in Windows, right? And we have two types of containers called Windows Server and Hyper-V as of now, right? I'm going to show what that each means. And so since Docker supports both Windows Server and Linux container system, the Microsoft public clouds platform supports both of these Windows Server and Linux containers as well. Say if you want to spin up a Ubuntu VM, which I'm going to do in a demo, and put some application into there in Microsoft Cloud, you can do it. So what is kernel level isolation? Now Docker is good, right? Because we have isolated the application layer out from the OS or the virtualized hardware and whatnot. But there's a challenge. I have parked all my containers inside a physical host, right? What will happen if it's a multi-tenant? I'm a hoster, right? I have my client's containers there, and somebody attacks my host environment. I will be still using the same shared kernel within that OS, right? Host OS, and it's vulnerable. And the other thing is, now one container might depend on a particular OS level, patch level like that, right? If I patch the entire host, put software updates in, couple of containers, so applications won't work. So that is again interdependent. Then Microsoft has these two names, but other providers like Linux has two different terms for that. They have come with two different containers. So one is Windows Server and the other one is Hyper-V. So Windows Server containers basically means you deploy a Windows Server and then you tell, okay, this is a container host. You just enable a feature called containers, right? Like you install any regular role in Windows, and then you deploy your containerized application there. And what do you mean by Hyper-V is, now Hyper-V is Microsoft's virtualization platform. If you are familiar with VMware or the Oracle box, you know what a virtualization hypervisor is. So on top of the Windows Server operating system, you deploy Hyper-V, right? And then you use this Hyper-V to create virtualized containers, right? And again, you can do it in two methods. I will show you in the later slide. So again, the advantage is here you are not using a shared kernel because the containers are again isolated by another virtualization tier. So if you take the Microsoft container runtime, as I mentioned, I have the physical server and I have deployed the Hyper-V hypervisor, right? And then on top of this Hyper-V hypervisor, I can just deploy Windows containers. Basically, I have a virtual machine that is running Windows, right? I'm using it. Or you can take this entire thing off and put your containers here without Hyper-V. Then you enabled Hyper-V hypervisor here, and you can just straightly deploy the virtualized containers. These are not virtual machines. These two are virtual machines, right? You can deploy like that. And then, how many of you have seen the movie called Inception? Leonardo DiCaprio. What do you see in that? A dream within a dream within a dream, right? Something like nested dream. So this is that. So with the release of Windows Server 2016, we Microsoft are able to achieve this, the nested virtualization. Here you have a virtual machine. Inside that virtual machine, you have enabled the Hyper-V hypervisor, or the virtualization platform. So inside this, you can put another virtual machine or a Hyper-V container, which is again isolated. Okay, so the DevOps process with containers. So as you can see, the developers create the containerized application, package them using maybe any development tools, and then push it to the containers repository, maybe Git, maybe GitHub, like that. Okay, and then the operations guys can use it to deploy the applications into the containers. So here we are talking about saving resources. You have, say you have 10 applications that is compatible with container method. you can maybe use a like one server, physical server to deploy that, where you have used 10 servers previously, or maybe 10 virtual machines. Okay, so yeah, now if you want to go for a little bit for demo how this works, I will show you one in particular. Okay, so now this is a small example. I am using Visual Studio 2015 with ASP.NET latest release candidate version. So suppose that I need to create a web app. Basically this works with web project. So I am going to create a new ASP.NET web project. Okay, here I am selecting web application ASP.NET. Something like this, and then it will ask me to create the application. I have a couple of templates. I am going to use a blank template here, and then when I want to publish these applications, it will allow me to publish this to Microsoft Azure as websites or like that, and I will have another option called containers. Basically I am using this using a preview tool called Docker tools for Visual Studio, where I will be able to deploy this application to a container running on a virtual machines. So this my virtual machine will be running on Azure, right? Now since this is a web application, one might ask, okay, where is IIS? I am not bothered about IIS anymore, right? I am just deploying this application to the container, and the host OS and the container will take care of the IIS itself, right? So for an example, if I want to publish this one, right click and publish. Okay, you have the option called Docker containers, right? You have a couple of publish options there, and it will ask, okay, where do you want to deploy this? Do you have any existing virtual machines? Yes, I have 2, but I am going to select as new, right? And here I can give all the details I want for that my container host or the host machine that these containers are running, right? So I'm using Microsoft Azure as my platform. I can select a location, I can give it a name, right? So if I say something like this and invest US, so here I will be able to select what is the operating system I want to use. So you can see the list of options. You have Ubuntu, you have ClearOS, you have Windows Server 2016 as well, right? So I can select anyone from there and a machine size for the virtual machine that I have been using, right? And a password, and then okay, it will then first create the virtual machine or the host that is needed for the container. It won't publish at the first point, right? Then once this is created, I am not going to create a virtual machine because I already have done one. So I am going to select one here, right? Then when that host is created, it will ask, okay, what is the URL, and you can see host port and container port, right? So now since it's a web application, it should run on 443 or port 80, right? But inside the container, how do we map that? Because we might have 10 containers. All containers containing these 10 web applications can't hit traffic for port 80. Here you do that network port translation. So if you have 10 applications, the host port might be 80 and the container port might be something else, right? You can validate the connection and then you can publish it from here. And it will take some time to deploy the application as a container. So if I go to the container that I have, sorry, the application, the .NET application that I have deployed. So this is actually a Ubuntu virtual machine. DNX is there, so I can run ASP.NET inside that, right? And there's a Linux container hosting this particular ASP.NET website. Okay. So how about Windows Server containers, right? So if I go to my Azure subscription and go to my virtual machines, I already have 2 virtual machines in place. One is empty, one is running, right? And this one in particular is a Windows Server machine. I will show you. So I have this one. Okay. So if I go to get container image, sorry. Okay. So as you can see, I'm not sure whether it's clear. I have 2 container images, right? And I will show you the code I used for this one, basically. So here what I did was, I used a base container image and created a new container, and inside that container I installed IIS. That is basically required to run the application, right? So that's I mentioned. If I'm doing this from Visual Studio, I'm not bothered about installing IIS. But if you do it like an IT Pro, I will be installing IIS. And then I use this template to generate another versioned controller, saying, okay, this is a IIS template which I can use, put any IIS website into it and deploy. And then this is the place where you do that port mapping. Port 80 traffic, if it comes with this particular container host to this container, go with that. Okay, so if I go to that particular virtual machine, sorry. Okay, this is its public URL. So this is actually hosting that IIS container that I deployed previously, right? I haven't deployed any web page, anything into that. And if you want to copy a file, let's say web config file and whatever to the container, you can do that as well. So you are using the SMB method, simple file sharing method, like you use run whack and followed by the file path you copy and paste. Everything is available there. And the container you can easily manage with this. If you want to do any IP address change like that, that also you can do. But people might consider, okay, is it really a virtual machine? No, it's a lightweight kind of virtualization. You don't have all those big binaries, all those files that an OS possesses. Okay, that's pretty much I got to demonstrate on my demo, and yeah, still have 1 minute. Okay, we gone through that. So the advantages of this technology I have discussed, right? And if you have any questions on what we discussed today, this was a pretty much of a introduction session. I know some people are actually working on that, but if you intend to use this with Windows Server at a production level, the operating system itself is not yet released. It's in a technical preview. You can go to the TechNet and download and use it. And the big thing is you can use PowerShell or this Docker engine to manage any of those containers. If you have any questions regarding any of these technologies, maybe Azure or maybe anything related to cloud, is my email address, my Twitter handle and my blog. You can just email me, tweet me, and I will be around here for that. Okay, and again, thank you for participating in my session, and I must really thank ExileSoft for having me here, and I hope that you will enjoy the rest of your day. Thank you.